slightly different type of problem. You may have noticed that in all of the examples we've done so far, we've integrated first with respect to r and then with respect to theta. But there might be times when it is actually advantageous to integrate first with respect to theta and then with respect to r. So it turns out that this is such a time. The problem tells us to find the area of the region bounded above by the spiral r equals pi over 3 theta, and below by r equals 1 and r equals 2. So pi over 3 theta, it's clear that we have a relationship between r and theta. We can think of r as a function of theta, theta as a function of r. But if we looked at this region in the plane, and there's actually this picture in your textbook. This is called a spiral, and it looks something like that. So if we take r between 1 and 2, say this is 1 and this is 2, what ends up happening is that in order to integrate this with respect to r first and then with respect to theta, you would have to split it up into two integrals, where you're integrating first here and then there. But if we integrate with respect to theta first, then it turns out we only need one integral. Well, it will be a double integral, but instead of two double integrals, one double integral. Okay, great. So let's think about what my bounds would be for theta. In order to find my bounds for theta, I'm going to solve this expression for theta and write theta as a function of r. So basically, if I just switch the place of r and theta, I get to say theta is equal to pi over 3r. So I just multiplied by 3 theta on both sides, and then I divided by 3r. I get this expression. So my integral, now my outside is going to be the r integration, and I know I'm integrating between 1 and 2 in terms of r. But my inside integration is going to be theta, and I'm taking theta from the angle 0 to the function pi over 3r. And then I'm integrating r d theta dr. So I still get the r from my Jacobian, but I just switched the bounds, switched the order of integration and switched the bounds accordingly. So this will be integration 1 to 2. I'm first taking an antiderivative with respect to theta, so this is just r theta evaluated between 0 and pi over 3r. And then I'll take an antiderivative with respect to r. So I have integration 1 to 2. Plug in pi over 3r, I get pi over 3. If I plug in 0, I get 0. So that's my integration. Nice and simple, integration 1 to 2 of a constant with respect to r. So we get to say that that's pi over 3 times r, and I want to evaluate between 1 and 2. So that's 2 pi over 3 minus 1 pi over 3, and pi over 3 is the value of the integral. So as you can see, that was very nice and simple, and I didn't have to split it up into two separate regions.